Hello and welcome again to my channel. This is the fourth and final video in this series. So what have we done so far? We have started with a raw data set with 300,000 records, and these records are stars and deep space objects, galaxies, nebulae, open clusters. We filtered out our data and retained 58,000 records, which we are interested in. We then created 14 million relationships between these records. This will enable us to access the data using a structure such as this. This is a more meaningful representation for people like amateur astronomers, since this will allow them to traverse the data and see how the objects relate to each other in the sky. In the final step, we will create a mechanism to access this data. This data is stored right now in my private S3 bucket. We will start by using API Gateway to build a REST API to expose this data to the internet. We will then create a lightweight HTML frontend, which will serve as the UI. So let's get started. Let's start by creating a couple of tables in Athena to allow us to query the underlying CSV files. Like I said, my data is right now sitting in two sets of CSV files. I have my 14 million relationships, which are sitting on this S3 bucket. And this is a CSV file, 14 million records spread across 8 CSV files. And they have the CSV format, they just don't have the CSV extension. I also have 58,000 stars and DSOs, and these will form the nodes in my database. And they are also sitting on a file which is a .csv on S3. So I'm going to go to Athena and I'm going to create two tables. So we go here, click this. I already have my data source and I actually also have my database created. But let me show you how to do this. And I covered this briefly in my last video. All you do is choose S3 bucket over here, enter a name for the table. You either create a new database or choose an existing one. Choose the location of your S3 bucket. So this is where my stars and DSOs are. If your source bucket is encrypted, you can select this. Athena does work with your data in S3 encrypted, and you are able to access data and query it. The only issue I found was that I was unable to sort the data when the data in the bucket was encrypted. And I'm not sure if that's a feature of or a bug or just the intended behavior. The data format is CSV because that's how we created our files. And then you'd go in here and in the order in which the columns are there in the file, you just enter the column name and you would enter the type. So I'm not going to do this. I've already done this. I can go to my table and pull out the DDL for you. So cancel out. So let me pull out the DDL for the stars and DSOs. And these are the columns in the table. And similarly for distances have got the ID to the source and the destination, each object, and the angular distance, which is a float. So I have my two tables over here, and I can query the data in the tables. So I can do something like select everything from based on catalog ID. So I can say find all the DSOs where the catalog ID is M, Messier, and the catalog name is M, Messier, and the ID is 13. I could run this. And that gives me the record. This is M13, Messier 13. And this is all the data from my combined V2. I can also do a join between two tables. So I can do something like this. I'm searching for M13 once again, but I'm trying to find all the objects in the sky closest to it as measured by angular distance. And I'm going to get the first 100 objects which are closest to it in the night sky. Run that. And there you go. So you have M13 right on the top, and then in the ascending order of angular distance, these are all the objects closest to it. So you start with the closest stars, and then you kind of move on and get the closest stars and DSOs. You see the angular distance increasing as we move out. So I have my query ready. The next step will be to expose this query over the internet as a REST API. The easiest way to do that is to wrap this query in a Lambda and then expose the Lambda over the API gateway. So I'm going to do just that. Here is my Lambda. I have the query that I wrote earlier over here. I will accept two inputs, catalog name and catalog ID, and this will be passed as a get function in the URL. I'm going to plug them into my query, and then I'm going to submit them to Athena. You see that I'm sleeping for 5 seconds over here. The reason is that Athena is not meant to be used for real-time query responses. What I will be doing with the query is submitting the query to Athena. Athena will queue it. I will wait for 5 seconds and then read the results. And this is fine for a POC. If you need faster results, you will need to load the data into something like an RDS and then do a real-time query. So I have a test event set up. So let me run that. So here you go. These are the same results as I got earlier. And now you create an endpoint in API gateway to access that Lambda. So you go here, create API gateway and choose REST API, build, REST, give it a name. This is good. Create API. So let's create a resource which would support the get method. So create a resource, call it let us support the get method. And here you would enter the Lambda that you just created. So it's Lambda function. So in the integration request, you have to make sure that when we pass our catalog name and the catalog ID, you got to make sure that gets passed on to our Lambda function. So our Lambda is expecting catalog name and catalog ID. So we're going to make sure that our get accepts those and passes them to Lambda. So integration request, mapping templates, create a mapping template. Save. When I call it, I'm going to call it from a JavaScript button on HTML. So you will need to enable calls by clicking this button over here. So you do that and then you deploy by clicking deploy API. I'm going to my stage. I'm deploying to production. And this is the URL which it gives us. So now this URL is publicly accessible over the internet. So let me go to Python and call it. Excuse me, I'll go to Postman and call it. So this would be my query. So this would be the URL that API gateway created. So I'm going to this URL query and a get method passing the catalog name and catalog ID. That's what I've done over here. Catalog name M13 from our example, and this will get. And here are the results. So JSON format, header on top, M13, and then all the other records. And there are plenty of controls that you can build in to restrict access to the API. I'm going to delete this API once my video is over. The final step is to create our static HTML frontend. The code for that is on my GitHub. So on my GitHub, index.html, and I won't go into too much detail here. This is standard HTML. So I create a table and I create a JavaScript button. Remember to enable CORS on your API gateway. And within my code, I plug in the gateway URL, which I created earlier. So now for the moment of truth. So this is my front end. This is what I created. So let's search for M13. And when I search for M13, you'll find that it waits for 5 seconds. This is in my Lambda. Again, Athena is not meant to be a real-time query response tool, but this works for a POC. So I have M13, I have the closest objects to it, stars and galaxies. And as you scroll down, you see the stars and galaxies which are further away. Lots of bells and whistles that can be added to this page. Right now, I have hard-coded it to give me 20 records. So let's do one more. And you see 2261. Again, it's waiting 5 seconds. And here are the responses. NGC 2261, Hubble's variable nebula. Again, the stars and DSOs closest to it. And as you scroll down, you get the ones which are further away. And there you have it. This is where I will end my POC. Of course, there's a lot more that can be done with this. One thing you could do is load the data, which is currently sitting in S3, into a graph database such as Neo4j. This will provide additional functionality like open-ended queries using Cypher. They also provide some nice visuals and navigation tools out of the box. I personally am looking for additional data sources. There are other astronomy catalogs with data on things like binary stars, carbon stars, which I would like to find and incorporate into this dataset. Thank you for your time. I hope you have found this useful. If you have any questions, please feel free to add them in the comments.